about a couple of filtering devices that are in your body that you need to know. So this is from chapter 14, which we skipped, but I'm just going back a little bit to talk about it today. This is on page 379. It's a naked guy and woman.
That's not fun.
Why don't we, can y'all pull the blinds open so we can see me a little bit? Wrong one. Yeah, that's it. There you go. Okay. So what this is a diagram of is your lymphatic system. Now, what happens is around your cells, let's go back here. This is this is a blood vessel. And a blood vessel brings blood in, and the blood branches off, as you remember, into little small vessels called capillaries. And it's at the capillaries that stuff leaks out of the blood. And like oxygen and sugars and water, and it's taken in by the cells so that the cells can get their nutrition. Every cell in your body is near a capillary. So capillaries are everywhere in your body delivering stuff to the cells. Now, what you probably didn't know is a lot of the water comes out of the blood vessels and washes over the cells and then goes into these green vessels here. They're not really green. They just draw them green in the book. But these vessels are called lymph vessels or lymphatic capillaries. And they take that water that has washed over the cells and they take it in. And the water goes down into these lymph vessels. And so basically, this is a way your body has of washing every one of your cells, cleaning it. Water comes out of the blood, goes over the cells, and kind of rinses them. And anything that was bad that's inside the cells will leak out of the cell at some point and be pulled into a lymphatic capillary. This includes waste products. This includes viruses that maybe have infected the cells or bacteria that have infected the cells. And all of that gets washed into these lymph vessels. And then the lymph vessels, the lymphatic capillaries all meet up in these green tubes that you see here, and all the junk is taken to these little nodules. You see all these little nodules all around these little circles here, all around the lymphatic capillaries, the lymph vessels, I mean. Those are called lymph nodes. Have you ever heard of those? And the lymph nodes contain a whole bunch of white blood cells. This is what a lymph node looks like. And the lymph, the water and waste and stuff, we call it lymph. It comes into the lymph node, and in the lymph node reside millions of white blood cells. And the white blood cells will kill any kind of infective agent or break down any garbage that was in your cells. So that's why it says macrophages, T cells. This is where white blood cells reside. The lymph does not have a heart pumping it to keep it moving fast. So the lymph moves very slowly, and it's kept moving in the same direction by these little one-way valves. So the lymph cannot go backwards, it can only go forward. So anytime you move your body around, like I'm doing now, these lymph vessels are being squeezed, and it's pushing the material forward. And into these lymph nodes, and then out of when it comes out of the lymph nodes, it's all cleaned. And eventually the lymphatic system, we go back. The vessels, all the material goes through these lymph vessels and eventually gets dumped back out around the heart. And I thought they had a picture of that. So there's what a lymph node looks like up close. It's kind of gross. Here you go. Here it shows. Up around the heart, the lymph vessels dump their material back into the blood. So all that water and stuff that was in the lymph vessels gets dumped back into the blood right around the heart in these vessels that lead to the superior vena cava. So all the liquid and stuff goes back into the blood, but now it's been cleaned. Have you ever heard the doctor say, "Oh, your lymph nodes are swollen," when you're sick? You ever heard that? So you've got viruses and stuff. They're multiplying like crazy, and all that gets into your lymph nodes. And your white blood cells that are in the lymph nodes start multiplying when there's more viruses. So the lymph nodes swell up real big. And that's how you fight disease. It's one way. Isn't that great? Now, there's another organ that you need to know. Not the heart, not the lungs. There it is, the spleen. The spleen is a real big organ. You probably saw it when you're doing your rat dissection. It sits right about here. It's only on your left side. It's one of the only organs that's not bilateral. You know, it's only on the left side. And it sits there and it strains the blood. It's like a lymph node for the blood. The blood goes into the spleen through the splenic artery and comes out of the spleen through the splenic vein. And when the blood's in the spleen is full of white blood cells. And the blood spreads out all into the spleen, and the blood is examined by these white blood cells. And the white blood cells will kill any viruses or bacteria that's in the blood, or break down any garbage that's in the blood. And here it shows up close in the spleen, the splenic artery breaks down and gets smaller and smaller, and the blood ends up kind of pooling in an area here, and all this gray-looking stuff, that's all white blood cells that will clean the blood. What do you think it would be like if you got stabbed by somebody and they stabbed you in your spleen?
It'd be blood.
It'd be a lot of blood, wouldn't it? Spleen really bleeds a lot. But it's necessary for cleaning your bloodstream. Some people have damage to their spleen because it's kind of a superficial organ. It's a little bit toward the outside of the body, and if you get in a car wreck or an accident or get shot or something, a lot of times your spleen will be damaged so bad that it'll have to get it removed. You can actually survive without a spleen, but your body doesn't clean the blood very well, so you usually have to take a bunch of antibiotics and stuff to help fight your diseases. We're studying a couple things, McLean here, and can you stop by after class? I've got stuff to hand back, and we need to talk about stuff that you hadn't handed in yet.
Yeah, I haven't finished mine.
Yeah, we need to talk about it. I got a little spleen video. You want to see the spleen video?
Do I?
What?
I got 6 kids today.
I was gonna have 2-3 periods before that.
No show.
I was.
I got you. Look at that.
Bone burn. I didn't even know if I needed to get curved today. I really didn't know if we had anatomy.
Quiet, please.
The key to the immune response, as it's called, is the lymphatic system, linking many different glands, like the ones that swell up in the neck. These are the lymph nodes, scattered all over the body at strategic points near where germs and microbes get in. Each node contains white blood cells that are equipped to detect invaders and manufacture weapons to destroy them. But first, the invaders have to be brought to the nodes to be identified. Since bacteria and viruses can get into any part of the body, particularly if there's injury, every region needs its own surveillance network. There's a circulation that's separate from the blood circulation, but linked to it. This contains a fluid called lymph that drains our tissues and carries away bacteria or viruses or broken down cells. These are then filtered out through the nearest nodes. Like many body systems, the lymphatic system does several jobs at once. For example, it carries fats in our diet from the intestine to the parts of the body that store them. The white appearance of lymph is due to the globules of fat that it carries. But the lymphatic system's most important role is as the transportation system for our defenses, filtering out invading molecules and microbes before they can get into the blood. Transportation of fluid continues slowly but steadily all the time. It's not as fast as the blood circulation because it hasn't got a pump like the heart. Instead, regular squeezes from our muscles outside the lymph vessels push the fluid on through the valves which stop it flowing back.
See the little valves?
Each area of the body is monitored by its own lymph nodes, most of which are quite small. But there's one part of the system which is much larger. The spleen. This is really the lymph node of the blood, and so it straddles one of the main blood vessels on the outlook for suspicious components. The spleen protects the blood from infection and removes useless or harmful cells. It's also a junkyard for old, tired red blood cells. Red blood cells are produced in the bone marrow and circulate for about 4 months before they start to show signs of tiredness and age. In particular, they lose some of their flexibility and become stiffer. The older red cells are spotted by other cells in the spleen and broken down to release useful components like iron, which can be used to build new red cells.
Isn't that funny?
I laughed.
All right. So that's basically the lymph system and the spleen. Now let's talk about the kidneys. Chapter 17. Turn to chapter 17. Page 470. Okay, so there's another filtering device that filters the blood of waste so that you can then get rid of it from your body. And those are your kidneys. And here are your kidneys. They actually sit toward the back of your body. So if you open somebody up and you're looking at them, there would be a bunch of intestines and stuff in front of the kidneys. Hopefully you realized that when you did your frog dissection, or we did a rat dissection. The intestines and stuff sit in front of the kidneys, and if you move those out of the way, you can see the kidneys. They sit right about here, and they filter the blood. You have this big vessel that curls down. It comes out of your heart and curls down. You know what that big vessel's called? The biggest vessel in the biggest blood vessel in the body, the aorta. Yes, it curls out of the heart and goes down through the body, and it has a couple branches that come off of it. One branch goes to the left kidney, and another branch goes to the right kidney. We call that the renal artery. If you ever see the word renal, that means kidney. Okay? And some of the blood goes into the left kidney, some goes into the right kidney. And inside the kidneys, the little vessels break down into smaller and smaller vessels, and eventually the blood gets filtered. I'm going to show you how that works in just a second. And the stuff that's in the blood that needs to be removed are usually poisons, stuff that the body doesn't need. The main thing that you pee out every day that you don't need is called urea. Urea is a nitrogen waste. When you eat protein, or when you build muscle, or when you break down muscle, and when you change things around, a lot of the proteins in your body have a nitrogen group associated with their amino acids. And that nitrogen group has to be gotten rid of if you don't need it. If you're not building protein, for instance, if you eat a lot of protein and you don't use it right away, you want to store it. The liver will change the protein into fat and store it. So you can eat all the protein shakes and all you want. If you don't work out and you're not using that protein to build muscle, your body will take the nitrogen groups off, make them into urea, and you'll pee them out, and the rest of the protein will be stored as fat. And so the yellow stuff that's in pee is from this process. It's from getting rid of these nitrogen products. And so the urea ends up in the bloodstream, and it's a poison. You have to get rid of it or you'll die. So the blood goes into the kidneys. The kidney removes the urea, push it down this tube here with some water. It drips down through the ureters, that's what these are called, and the fluid collects in the urinary bladder. And it just slowly drips down and builds up over several hours, depends on how much water you've been drinking. It's also a way for the body to get rid of extra water that's in the blood. And then eventually you pee out through your urethra, the pee comes out. And it contains most of the nitrogen waste. It'll also contain anything else that's in your blood that's not necessary. Drugs that you've taken, aspirin, Tylenol, it all comes out of your body through your pee. That's why they have you do pee tests, to test you for drugs, because all of that's not supposed to be in your body, and it'll all come out through your urine.
Is your kidney, does it fully filter all the things that doesn't need to be in your blood, or does it sometimes leave things behind?
It can leave some things behind, but it'll get most of it. But your blood will go through it over and over again, you see. So
isn't it right that people who drink a lot have bad kidneys?
Absolutely. And that's because the alcohol is a poison. And having to be filtered and such, it'll kill cells in the kidneys. It'll also screw your liver up, which is responsible for breaking down the alcohol. So here's a kidney here, and I want to show you the little filtering device in the kidney. Each kidney has about 1 million of the filtering devices, and the filtering devices are called nephrons. So if you take a look at here, here's a kidney if you were to cut it open. And see this little square here? They're taking just one little rectangle out here, and they're showing it to you pretty largely. And here you see a lot of little curly tan they look like little vessels or something that are all coiled up. One of those, if you look at it closely, this is what it looks like. It's called a nephron. That's what this is. This is a nephron. And the nephron are filtering devices. The kidney's full of them. There's about 1 million nephrons in each kidney. And here's how the nephron works. Let me go to this picture. This picture shows it best. There's a lot of pictures of nephrons. But here we go. Here's a little blood vessel. And it's carrying blood. This is from the renal artery. Carries the blood this way, and there's a ball of capillaries called the glomerulus that is surrounded by the first part of the nephron. The first part of the nephron here is called the glomerular capsule. It surrounds the glomerulus. So, and here it is up here, seen larger, or seen smaller, I guess. The blood comes in, goes into the glomerulus, and it's surrounded by this glomerular capsule. When I was y'all's age, it was called Bowman's capsule. But now they've changed it to glomerular capsule. I guess they kind of screwed Bowman out of his discovery there. I don't know how that happened. Bowman, wherever you are, I remember, buddy. He probably died, and they said, we don't need to call it that. That's what they'll do. They'll name something after you, and then when you're gone, nothing. You wait. Anyway, the glomerulus, the blood comes in. The glomerulus has little tiny holes in it. And almost all the stuff comes out of the blood in the glomerulus. The blood cells can't get through the little tiny holes. But the water and sugars and waste products and hormones, almost everything else does. And so a little bit of the water in the blood cells stays in the blood and continues on, but most of the stuff comes out. And then most of the stuff goes through this curvy tubule that curves around and around. And in this area where this curvy tubule is, here we see, here's little arrows with the green, that stuff coming out of the blood. Are y'all with me here? What's going on? Hold on, I want to show you. No, they don't have a good picture of it here. Wait, let me go back. This is a good picture of it. As all the stuff that was in the blood, even the good stuff now that's in the blood, as it continues down this curvy tubule, you can see it's surrounded by blood capillaries. And what will happen is these blood capillaries will take back all the good stuff that was in the blood. You don't want to pee out your good stuff. You don't want to pee out sugar and salt and stuff that you need in your body. You just want to pee out the waste. So all the stuff comes out of the blood in the glomerulus, and all the good stuff is reabsorbed by all these blood vessels. This big loop down here, look, they call it nephron loop. You know what it was called when I was a kid? Henley's loop. Henley, you and Bowman. Both of y'all. They've ripped you off. Anyway, as the stuff continues down Henley's loop, the water, most of the water gets reabsorbed there, and the sugars and salts all get reabsorbed by these blood vessels, and all that's left by the time the nephron ends is the waste products and some water. And that continues down this collecting duct and ends up going to the bladder. And here's the bladder. All the waste and water goes into the bladder, and the bladder fills up. The bladder is stretchable. It's got what we call transitional epithelium. Do y'all remember that? Stretchable epithelium. And the bladder will get real big and full of pee, and you'll be like, I gotta go pee. And there's a muscle right here. No, wait, that's the prostate gland. I'm sorry, this is in a male. There's a muscle surrounding this right here, I guess is where it is, that a sphincter muscle that holds it shut. And when you relax that sphincter muscle, the pee comes out. like I said, as you get old, your sphincter muscles all get weak. And so, some old people kind of pee by accident. They lose control of their bladder a little bit. And so, you got to wear those adult diapers and stuff. That's what you have to look forward to. I remember a buddy of mine in college, he decided that he was going to be funny, and he'd go out to the bars and he'd wear an adult diaper, and he would just pee into the adult diaper instead of going to the bathroom. Well, what he didn't know is the adult diaper is just made to catch the little bit of pee that dribbles out of an old person that they can't quite hold in. And so in the middle of the bar, he starts peeing into his adult diaper, and it just soaks his pants like he's just peeing himself. I'm like, real smart. First of all, you wasted $20 on adult diapers for no reason. And now you've peed yourself in the middle of a public place. Oh, it was hysterical. I mean, it was. All right. So that's about it for the kidneys. So I want you to read 17.2 tonight, and tomorrow we will do a gallbladder removal surgery, and maybe a quiz on 17.2. And you got to remember to take your test if you haven't taken it yet. Okay.